Welcome to e-learning. It's been 5 weeks since our quarantine started, and came the day we had to stay home. And your kind smile I've missed since we parted, but you miss my tie flips 1,000 times more. Where, oh where are you today? Why did you leave me here all alone? I searched the world over and thought I found students, but they closed the school and we was home. Happy Wednesday, everybody. I hope you were at least 6 feet back when we were singing that song. That song could get you, and so make sure you sing that song. You need to social distance for sure. But when I was young, I always loved hee-haw, and maybe you don't know what hee-haw is, but your parents probably know, and for sure your grandparents know. In fact, I have a couple pictures for you. When I was little, I found this picture at my parents' house. There's Mr. Nyson, and he thought he was tough. He had his fire hat on, he was riding his big wheel, and if you look closely, he has hee-haw overalls. You can see the he, you can even see the haw upside down on part of that, but those hee-haw, I love those hee-haw overalls. But I was one tough dude back then. And then I also, since we're being a little nostalgic, I found a picture from Christmas. Here's Mr. Nyson Christmas morning getting Batman and Robin, and who would know that years later that Mr. Nyson would grow up to be Math Man, chasing down his students who don't do their e-learning. And so make sure you get that done. But I love those Batman and Robin toys also. But if you really want to see one cute dude, it's this next picture right here. This is Mr. Nyson at age 3. And so, yep, I have to say he's pretty cute, if I say so myself. Do you see a resemblance? Maybe no glasses? Do I look the same? And so, hey, well, welcome back to this Wednesday. And we want to make sure that everybody has everything they need. And so hopefully you're on the school website and you've already filled in the attendance form. And so we'll give you a second to fill in the attendance form, and you fill it in, and then we'll be right back. So you pause the video, fill it in, and come right back. What we have in store for geometry today. And so let's go right down here. And we're going to talk about composite mappings. We're going to do reflections and rotations and half turns together. And so we're going to talk about composing them together. And so tonight's assignment is page 603, problem 1, problem 3, 5 to 12, 17 to 24, and 27. And I do have a handout. Handout would be very helpful to use that. And you need to use your mirror also. And so make sure you have that ready to go. Also, the logic problems, very important. We need you to do this. This is a real contest that the top 5 scores give our school score. And it's like a national thing. And plus we have individual prizes and rewards for you in this class. And so set 50 minutes aside. So if it's a sunny day or if it decides to rain, set time aside, do your best, and get this thing done. It has to be done before tomorrow night, or you'll log in and go, it didn't work. He who snoozes loses. And so make sure that you get this done. And so get this done today or tomorrow morning or early afternoon. Don't wait. And so also your warm-ups on Khan Academy, get the 3 new ones done. And if you messed up and you didn't finish some of them, Tim, make sure you get those done. And so we need those warm-ups done. Do the old ones. They won't be late. Well, just get them done. And so we want to make sure you get everything done. I sent you username or password for the logic. So here we go. We're going to start in on composite mappings. And we're going to do multiple things at once. And so we're going to reflect. And then we're going to reflect again. And so what we're going to do is take your mirror that you have. And got it. Make sure I'm getting these things back along with your textbook. So we'll be getting all this stuff back from you. I'll let you know how when I figure out how. But we're not done with school yet. And so you put that mirror right here on this first line. And we're going to reflect, well, the mirror's red, so this better be red. We're going to reflect this triangle across this first line. And so right here, if I reflect this triangle, I'm going to cheat by hitting some buttons. But you take this, and we could call this triangle A, B, C. But if I take this triangle right here, and then I want to flip it across like a y-axis, it's right there. And then this would be my new A prime, B prime, C prime. See right there. And that would be a reflection. Then what we want to do is, I'm going to start with this. And then I'm going to highlight this. We'll see if I can get all this technology stuff correct. Whoop. Give me this. Transform. Flipping the y-axis. You see then that. Okay. Follow me. Come walk with me. That'd be here. And then we want to flip that one across the new line. And so we're going to flip this across this y-axis. So what we did was we moved the mirror now to here. And then this one flipped over to here. And so we did a reflection, then we did another reflection. Now what do two reflections equal? Let's see. Here is the original one. And here is our final one. And how does that original pre-image, the pre-image, image, and then the next image, how do those two relate to each other? Well, those would just be a translation. If I look at this, going from here to here, or going from here to here, it would just be a translation. And let's see that. And if I move this arrow a little bit, from there to there, that's a translation. So let's fill in these notes, and let's move me up here. Hello. And so composition reflections in two parallel lines. If your mirrors are parallel to each other, if you flip a flip across lines that are parallel, the answer is simply going to be a translation. And you could, if I was standing up in class, I could flip around, then flip around again, and you would notice that I have moved right across the floor. And the distance of this translation, how does it relate to the distance between the mirrors? Well, let's look right here. Here's the distance between the mirrors. This distance right here is equal to this distance. This distance right here is equal to this distance. So the distance between the mirrors doubled this distance right here. This plus this actually gives you the distance between the mirrors. And so the distance of the slide is twice, 2 times, twice the distance. I wish I could write in cursive with a mouse. I have not mastered that skill yet. That could be next. Twice the distance between, this is way too much right, 2 right. Twice the distance between the mirrors. So if you want to move something a certain distance, set up 2 mirrors that are half that distance, and you just flip the flip, And you'll put an image over here that's not really there, and it'll just be smoke and mirrors. Oh, yeah. Well, let's do a double reflection across two things where the mirrors are not parallel. Okay? So you ready for that? Okay? Everybody ready? And we're going to flip a flip, but then we're going to do it across. Instead of the mirrors being parallel, we're going to do them being perpendicular and see what happens. And so we're going to take this. Whoa, that's not a good line. And this shape right here. And we're first going to reflect it across the y-axis. And the way we're going to write this on our homework is we're going to say reflect. A cursive R would be like rotate, but reflect across the y-axis. And so if you do that, your shape, let's see if I can do this. Let's go to here, let's go to transform, let's flip across the y-axis, and that would be come on, right here. And then you'd have that shape right there. Then what you want to do is we're going to flip that across the x-axis. Well, the way we do this when we do composition of functions or composition of mappings, you start at the right one and you do that one first. Then you do this one second. And so this would be a reflection across the x-axis. Here's the y-axis, here's the x-axis. And so if I want to reflect this, you can draw it here. But then if I want to reflect this across the x-axis, it would end up down there. And so what we do have is a composition of reflections into perpendicular lines is a, how do these two relate to each other? What would it be, Charlie? A rotation? Yes. But what special type of rotation, Charlie? What's that called? A half turn. So a reflection across the y-axis composed of reflection across the x-axis is a half turn about the origin. And we can do math with transformations. And it's pretty cool. And so that would make a half turn about the origin. And so it is a half turn. 180-degree rotation. It is a half turn. And so that would be a half turn. And this is the origin because that's where the x and y intersect. But it's always about the point where the mirrors, where the lines of reflection intersect. Okay? And so we have two flips if the lines are parallel. Would make a slide to the left. But if we have perpendicular mirrors, then it makes a half turn. Well, that's interesting because the mirrors are at 90 degrees and the rotation ends up being how many degrees? Carson? Yes, Mr. Nyson? 180. And so if your mirrors are at 90, the rotation is 180. Does that always work that way? Whatever angle your mirrors are at, your rotation is twice that? Let's see. Let's do another example and see if he's right. And so, see if all three Carsons are right. Here's a mirror. We put them at this angle. If we reflect twice, will it be at twice the angle of rotation? So here is my shape. Now what you got to do is turn your head sideways because we're going to go across. This point would be there. That point would look somewhere like that. And this point would probably be right there. And this one would probably be over a little more. And so if we flip across that line, this would be to here. Okay. Then we're going to turn our head this way. Which way? And, whoa, I need a different color mirror. We'll do red and yellow for McDonald's. Anybody been to McDonald's drive-thru lately? I haven't. And so I'm missing my bacon, egg, and cheese McGriddle. And so if we flip to here and flip to there and then go here to here, and then we go here to here, 2 flips across intersecting lines, this would be a rotation. And so this one would rotate to give you this one. And the rotation would just be twice the angle of the mirrors. And let's show you that. And the way we can show you that right here is if I went from there to there, and then I went from there to there, let's look at this. This angle from here to here is equal to the angle right there. And the angle from here to here would be equal to the angle from there to there. And so sure enough, it is twice. So composition of reflections in 2 intersecting lines is a rotation, just like it was when they were perpendicular, of 2 intersecting mirrors, lines, is a rotation, because a half turn's a rotation. And about the point where the lines of reflection intersect. That's way too much to write, so we'll just say where the mirrors intersect. Your red ones are actually called mirrors, made in Canada. And the measure of the angle, again, is twice the angle from the first line of reflection to the second line. Okay? So you got all that. So you need those conceptual ideas, and then the homework at the beginning is very easy. So we're going to finish up the notes here. And so everybody ready to do the last section? Okay? So let's talk about this last section, because a lot of your homework is going to be very quick, and it's just going to be writing a simple answer. But the hardest thing is when you do composition of mappings, you do this one first. And so it's going to say, we're going to take the point A, and we're going to reflect it across the y-axis, then we're going to reflect it across the x-axis. So you do this first, and then we're going to do this second. Okay? And so if I take point A, and we're going to reflect it across the y-axis first, we end up at point D. Then you take point D and you reflect it across the x-axis, and where are we going to end up? Where are we going to end up, Grant? Point C. Oh, I see what you're doing. Point C. And so then we do the next one. We're going to take point A and we're going to reflect it across the y-axis. Well, you go to point D. And then you're going to reflect it back across the y-axis. Woo! And where are we at? Back to where we started. And we'll give you an A for that one. And so that's point A. Let's do the next one. Start at point C. We're going to reflect across the y-axis. And so if we're at point C and we reflect across the y-axis, we're going to end up here at point B. And then this means we're going to half turn about the origin, which is a 180-degree rotation. So Urbanski, if we're doing a 180 rotation about the origin, where are we going to end up with? D. Great job, Jack. And so that one's going to be point D. Okay? Now let's go B. We're going to start at B. We'll go blue. It says reflect across the Y. Well, here's the y-axis. So we're going to go over to point C. Then we're going to half turn about D. Well, here's point C. And if we're going to half turn about D, we're going to flip 180 degrees around D. And we're going to end up with, which one would it be? Vadim? Yes. F. Very good. Now, maybe we should erase some of this so I can clear it up for the second half. For the second part, We're going to take point B and we're going to reflect it across Y. So we take point B and reflect it over to Y. So that means we're going to go over here to C. Now this says we're going to dilate, we're going to double it about the origin. And so if you're going to dilate, you're coming from the origin to point C. And so you'd end up there, right there. And what we want to do is do that again. So to dilate it, you're going to go out again. So that's going to be G. I wonder what the answer is. It's going to be point G. Woohoo! And so now we're at point D. You might be getting the hang of this. You can have me talk twice as fast and fast forward to the video and put me on 1.5 speed. And so if we're at point D, we reflect across the X, we go to point C, and then we reflect across the Y, and then we go to point B. Did you know you could watch the YouTube videos at 1.5 speed and then hear me talk twice as fast? Or if I'm already twice as fast and then you hit it twice as fast, then we're at 4 times as fast. And so if we go across the X and then across the Y, then we're ended up at point B. If we start at point C and we half turn around the origin, woo, we end up at A. And then A, we're going to reflect across the Y-axis, and then we're going to end up at D. If we start at B, remember we're just doing them this direction. If we start at B, we half turn to D. And then D reflected across the X-axis, we'll end up at C. Let's start at O, that'd be the origin. If you reflect a point on the X-axis, yeah, right here, X-axis, and you reflect it across the X-axis and you're in the X-axis, Eileen, we don't go anywhere. It's kind of like quarantine. You just stay home. And so that point is staying home on the X-axis. And then this point, when you half turn it about D, you take the origin, we reflect it to X, stays put, and then we half turn it. It's going to end up with E. Quit scratching your fingernails on the chalkboard. It's just E. E. And so, I wonder how that sounds 2 times fast on YouTube video watching. And then, let's look at this last one. It's getting messy over here. And so, if we take this one and we want to dilate point G halfway towards the origin, that just means instead of going this way, we don't want that. Get rid of that arrow. It's pointing the wrong way. And so it means we want to come in towards the origin. So half, we're going to come in half the distance to the origin. And so that would make G become a C. And then when you reflect C across the X-axis, it becomes a D. Okay? So some of your homework is just going to be looking at a picture on that. And then I got the sound on my face, so we got to get rid of that. Okay? So, hey, now let's look at some of your assignment. And so the first problems on your homework, I copied the whole thing. And so just like in algebra, when you do, we used to write function composition like this. We would write G of f of x. Well, that's function composition with function notation. Well, when you do function composition with like mapping notation, it looks like this. Sometimes we call it fog notation. You're like in a fog. But we do f of 2 first. And so you would plug the 2 in here, and f of 2. Bing! What do we get? You would get a 4. And then we would do g of 4. And so we would plug that in. And then you plug the 4 in here, and 2 times 4 minus 7 would give you a 1. And so that's what the answer is, just written a different way. Oh, wait a second. I think I got it. Oh, looky here. We rescued it from quarantine, the function machine. So we're ready to go. And then we're going to plug in, what is f of g of x? Remember on this, you do this part first. And so we're going to take the x squared We're going to plug that whole thing in here. And when you plug an entire x squared into the function machine, you get 2 times x squared minus 7. Okay? And then C, we're going to do the g of 2 first. So plug the 2 in here. What is 2 times 2 minus 7? Oh, 2 times 2 minus 7. That would be a negative 3. And then we would do f of negative 3. And you plug the negative 3 in here, and negative 3 squared, a negative times a negative. What would it be, Avery? Positive. Very good, and that'd be a positive 9. Then for the second one, you're going to plug g of x all in for x. So this really becomes the quantity of 2x minus 7, quantity squared. And then we got to see who can FOIL that out. Of course, Isaiah, the FOIL champion of 2019. Woo-hoo-hoo! What would that be, layman? What's quantity 2x minus 7 FOILed out? 4x squared minus 28x, because it's minus 14x doubled, plus 49. Excellent job. So, problem 3. We'll let you do that one. Just do the h of 3 first, and then take the answer, and then plug it into k, and you solve those. And then, for this one, put me down here in this corner. When we talk about problem 5, or we talk about the other ones, you look at the problem. If it says, reflect across J, reflect across K, I don't remember which one's which. But if you do this one first, then if it'd say reflect across K, reflect across J, whatever one is on the right, that's the one you're doing first. And so that's why it looks like I have the same problem twice. Problem 5, problem 5. You write which one you're doing, and then show me. Like if you reflect across J first, you're just going to end up right here. And then if you reflect across K, you'll end up right here. But if you reflected across K first, this image is going to end up like down here. Then if you reflect across J next, this image would end up being way up here, which you can't even see because it's off the screen. So I'd be doing that one down here so it would actually fit. And so notice how you get different pictures, and you need to realize that, okay? And so the same thing's true on the moon one, which one you're doing first. And then when we do these half turns for number 7, you do the half turn around A. Well, if you take this and you half turn it around A, it's going to end up something. You can draw a better picture. I'm drawing with a mouse. You can do better than I do. And then that would be your new one. Then if you rotate it around B, that one will end up being over here. Okay? But if you take this shape and take this one and turn it around B right away, you're going to end up over here. Then, if you take this shape and rotate it around A, that means this distance from here to here is going to be the same distance from your new half turn, plus this is going to be flipped, it's going to be turned. So it's going to be like over here. And so that's a totally different, this mapping ends up in a totally different spot than this mapping. They are not commutative. And so don't think they are, and you're going to show me that. Okay? Same thing here. You do these. Number 9, when you dilate something in a third, remember there's like little rays shooting from the center of dilation to the corner. When you're dilating in a third, it's like you're coming in a third of this distance. And so that's how tiny little your flag's going to be. Your flag is going to be right there. That's dilating at a third. And then you half turn it around E, which will make it turned. But if I half turn it first, this will end up here. And then you'll be coming in a third of the distance. And so will I end up here, or would I end up here? And so you need to realize that, okay? And so I want to come a third, and you'll be here, just like you were before, okay? And then very end of your homework, can't see it because I'm in the way, you read problem 10, and then draw it out, and it should be fine. Well, that's not the end of my homework. Wait, I got the whole backside. This backside's pretty easy because you're just naming points. Half turn around M, S goes around M, that goes to R, and then R half turned around, that would end up at Q. So A is Q, plus 11's odd. You can check it in the back of the book. And then you got problem 12, and then I got 17, 19, 21, 23, and so on. And then 18, 20, 22, 24. Sorry, they're not in order. 17, 18, 19, 20, 21, 22, 23, 24. But I just kind of grabbed them out of the book to make it easy on you. And so that's how they were in the book. And so, but they're all right there. And then here you want to use your mirror. You want to reflect A across line J, and then reflect it along line K and end up at B. So if here's line K, that's your second reflection. So the question is, where's my first reflection? Is it right here? If I reflect A across here, I get here, and then if I reflect this across K, would I end up at B? No, no, no. So that's not right. You figure out where that first line of reflection is. Hint, hint, work backwards. First reflect B across K, and then where would you reflect that point to end up at A? Where would the mirror line be? And so you show me and use your mirror and see if you can get it to work. Okay? So email me your questions. Hey, we miss all of you. And so hopefully this helps. And just let me know. Okay? And the sun's trying to come through again. So, hey, we'll see you later. Having a good Wednesday.